What's up, guys? It's Mr. Brengle, and today we're going to be talking about the difference between distance and displacement. So you should have already watched the video or learned about scalar and vector quantities. And so just as a quick review here, maybe pause the video, and I'm about to circle right below distance and displacement. They're the words magnitude and direction, and I'm going to circle which ones go with which. Okay, so distance is a scalar quantity, meaning that it just tells us how much, which is the magnitude. So I'm going to circle magnitude. It does not have direction, so I'm going to put an X through that one. Okay, now on the flip side, displacement tells us both magnitude and direction. Okay, so I'm going to circle both of these here. It has magnitude and direction, and we're going to show you kind of how that works here. So before we do that, let's talk about straight up definitions here. So distance would be the total ground that you cover while you're moving. So for instance, on this little chart that I have here, if we start at position A right here and we move to position B, and then move over to position C, you have traveled a total distance of 13 meters, correct? Because we moved 3 meters from A to B, and then an additional 10 meters from A to C, okay? So that would be 13 total meters, all right? Now, this is a little bit different from displacement because remember, displacement includes direction, okay? So if we were looking at the distance versus the displacement from A to B, well, it's the same because they're both moving the same direction, okay? But when we look at, if we go from A to B and then B to C, our displacement's not going to be the same as the distance. And that's because the definition of displacement is the straight line distance between your initial and final position. So if our initial position is point A and our final position is point B, then really what we're looking for here is this green line that connects them, right? That line right there. That would be the straight line distance between our initial and final position, okay? Another way to say this would be how far out of place is that object, okay? So if it originates at point A and then ends up at point C, how far away from point A is that object? And another way to say that would be the change in position. And I'm actually going to write this out. Change in position is designated by this little symbol, a triangle, which is the Greek letter delta, okay, delta X. This means change in position, okay, change in position. I was trying to get a little glitch with my computer there. So change in position is designated by that little emblem right there. And really what that means is the final position minus the initial position. So in this case, our final position would be point C and our initial position would be point A. Okay, so that kind of makes sense then with that definition, straight line distance between your initial and final positions. Okay, so I'm going to go ahead and let's go ahead and take a look at the difference between, even though we've kind of already started talking about the difference between distance and displacement, moving from A to B, A to C, A to D, so on and so forth. Okay, so the first one here is the distance from A to B. That's easy, it's just 3 meters. Okay, now on the flip side, the displacement from A to B, also 3 meters. They both moved in the same direction. So whenever you're moving in a straight line and you don't change direction, the distance and displacement are going to be the same thing, okay? Where this changes would then be what we just talked about when we turn the corner and move to C. So now the total distance, we already talked about it, is 13 meters when we go from A to C because we move up from A to B 3 meters and then we move 10 meters to the right, so a total of 13 meters. Now, we already talked about how it's really the green line, that straight line distance between A and C that we're looking for when we look at the displacement from A to C. So that would take a little bit of math there, use Pythagorean theorem to figure out the third side of the triangle. I've already done that, and it comes out to be, when rounded, 10.4 meters. Okay, so the distance traveled to get to point C was 13 meters, but the displacement from A to C, that straight line distance between them, is 10.4 meters. So what that means is that when you take the position at point C and subtract the position at point A, that would give us 10.4, okay, the change in position. All right, now we go ahead and turn the corner from point C and we go down to point D here. So in terms of distance, we've moved another 3 meters. So we're going to add that on here. So this is 16 meters now. Okay. Now displacement. Once again, remember, this is just the straight line distance between A and D. And that's labeled on this chart for us, on this graph. It's 10 meters. That's all you have to put here. We don't have to include anything else. He's simply 10 meters to the right of his starting position, okay? And to be honest with you, we should have, let's go ahead and put cardinal directions on here. So for this first one from A to B, I'm gonna say that was moving north, which would make the 10.4 meters northeast because it was diagonal, right, going this direction. And then from A to D, this would be 10 meters east, okay? Now, the last one here, if we turn the corner and we go back to our starting position, so we just walk in a big rectangle there, the total distance, we would then need to add another 10 meters because there's 10 meters between A and D. So the total distance traveled when going around the entire rectangle would be 26 meters. Okay, 3 plus 10 plus 3 plus 10. All right. Now, this is where displacement gets a little bit interesting because we went all the way back and we started and we ended at point A. So if you take your final position, which is point A, and subtract your initial position, which is point A, then your total displacement would be 0 meters. Okay, 0 meters of displacement. And that, again, is because of that definition. There is no change in position ultimately. If we end up back in that spot, we're in the same position we started in. So if you think about this in terms of, think about track and the distance runners on the track. Maybe they're doing a 1,000-meter race, right? Well, the total distance that they travel during that race, they're going around in a circle, right? And they're traveling a large distance of 1,000 meters. But ultimately, when they come back around and they cross that start finish line for the last time, they've ended up in the same place that they started, right? So their displacement is 0. And I always joke that they've accomplished nothing, right? They've ended up in the same spot, even though they moved 1,000 meters. So just want to make sure that you guys are understanding the difference between this. Make sure to ask questions in class. You'll have an accompanying worksheet to go along with this. And in the next part, we'll build off of this and talk about how distance and displacement feed into speed and velocity.